up the topic of bonding with something called allotropes. Alrighty? So here's a go. Let's go. Got this guy right here. Okay. Got this guy right here. This guy right here. Okay. And I got this guy right here. So what do they all have in common, people? Alright? They have anything in common? Something different? Alright? Now all these guys, folks, are made of the element carbon. Okay, in the pencil we got graphite right here. This guy right here is called Buckminster fullerene ball or buckyball. Okay, it's found in space. It's a pretty unique and cool arrangement of carbons. There are many different numbers and sizes of them, and they come in this spherical shape right here. Okay, and this guy right here, folks, is one structural arrangement, a way of representing diamond. Right, they're all carbon. Now the thing is, we know diamonds are very, very precious, right? And graphite is not so much. It's important to us, but you know, they're different values. Now we agree diamond is one of the most hardest substances known to man, and graphite, you could pretty much break it simply, easily. That's no problem. Okay, so how come is that? So let's delve into that. Okay, alrighty. So what are we looking at? We are looking at allotropes. Okay, then. Allotropes. And the definition of allotropes is different forms, okay, of the same element. Okay, very important. Now the thing is with allotropes, guys, you don't have to memorize every last example of them. What you need to know is, like I said before, foundational, you gotta know the definition, right? So it has to be the same elements. If they present a situation to you and they ask you, are these guys allotropes, or what caused them to be allotropes, you're good to go. You don't have to worry about every last situation, but know your definitions. Okay, they're different forms of the same element, right? And what causes the main difference? For example, in earth science, you may have learned, right, that intense pressure, okay, and intense heat causes the formation of diamond versus the formation of graphite, right? And they have different properties based on that. So some allotropes are just naturally that way, and some are formed by the external environmental conditions. Okay, but we don't have to worry about that too much. But just know that they're different forms of the same element, and the fact that they have a different structural arrangement. Alrighty. Because of the different structural arrangement, that causes them to have different chemical and physical properties. Okay, so they have different chemical and physical properties based on the fact that they have a different structural arrangement. I'll try and give you some other examples of famous allotropes. There's different types of phosphorus. Okay, there's red, black, okay, and I think white phosphorus, P right there. Okay, they have their own different unique properties. They're still phosphorus, right? But they have different melting points and so on. Okay. Famously, there's oxygen, O2, and ozone, O3, right? Oxygen, we know we breathe it in every day, we need it to live. And ozone, if you actually breathe it in, it's kind of toxic for you, right? But they're both made of oxygen, okay? Different structural arrangement again, okay? And there's sulfurs that are also allotropes of each other. Now, the names of those guys, there's rhombic, okay, rhombic sulfur. Alrighty, and there's also something called monoclinic. Okay, monoclinic sulfur. Okay, am I spelling that right? Okay. Let's go to CO, monoclinic. Alright? Okay, monoclinic. Monoclinic looks like more of a needle-shaped type conformation, and rhombic, I can't draw it because my art is kind of suspect. But rhombic looks like two rhombus stuck together like that, no problem. But you don't have to worry about the examples, as I said before. Just know what? Know the definitions, the different forms of the same element. So there's different kinds, there's different allotropes of sulfur, there's different allotropes of phosphorus, there's different allotropes of oxygen, and there's different, okay, there's different allotropes of carbon. Okay, buckyball right here, this is diamond, and this is graphite. Okay, so no problem. All right, guys, study hard, take care.